Okay, we are looking at solving multi-step equations, and this is where some special cases are going to take place. And so let's just start by working out a few of these problems. So first, I've got one that has over here some distribution that needs to take place. So I will, oh, there we go. Now it's wanting to work. I will do some distribution there. So, and just because we got a fraction, again, don't be worried about it. I can just put that in the calculator to multiply. What I end up doing is 1/3 times 21, which is just going to be 7x. And then I'm going to do 1/3 times a positive 18, which is going to give me 6. And sometimes that's not going to do what I want it to. So it's going to be a 6. And we can just copy the rest down. 6x minus 3 equals 7x plus 6. And going through our steps that we've been doing, we'll separate that. And then I'm going to move all my variable stuff over to the left, everything else to the right. So if I subtract 7x from both sides, that gives me a negative 1x, or we could write it just as negative x, minus 3, and that's going to equal to 6. Continuing on with it, I'm going to add 3 to both sides, and that gives me 9 on this side equals a negative 1x. So really what's going to happen is we're just going to change the sign, but you can think of it as dividing by negative 1 if you need to do that. Let's see if I put that on that. That makes it easier. Okay, and so what I end up with is x equals negative 9. So that's our answer there. We get one solution. To our problem. And so that means that I can put in a negative 9 for x when I check it here, and that's the only number in the whole world that'll work for that. Let's look at the next one. Going through our steps, we have some distribution to do first. So 2 times 4 gives me 8x, and 2 times negative 3 gives me a negative 6. Then I'll copy the rest on this side, minus 5x, and then on the other side I have 3x plus 5. So we've got some combining we can do, and again, you might do these steps kind of all at once. I'm writing them out so you've got some differences you can see. So 8x minus 5x gives me 3x minus 6. That is combining like terms. So I've got those two that are like terms that I just combined. Then I have 3x plus 5 over here still. And so we're already noticing a couple things. One is that I've got, oh, that doesn't work. I've got over here some stuff that is going to look the same. If I subtract 3x on both sides, that has the potential to cause some problems for me. So let's go ahead and work it out and see what happens. Do minus 3x on both sides. Is going to give me, well, those cancel out, and those are also going to cancel out. And so I end up with 5 equals -6. Okay, and so what I have there is, and I can look at that and say, well, is that a true or false statement? That is, of course, false. And so what that means is, when I get a false statement like this, and if we look kind of up here at this, this one up top here, we notice that like 3x and 3x for both of them. So if I thought of them as lines, the left and right side, these would actually be parallel lines. So when they don't cross like that, that's when we're going to say there is no solution. Okay, and last but not least, we got one more to work out. So doing some distribution again. 6x, and then a -2 plus 9, and we can go ahead and do that. 9 minus 2 gives me 7, and remember that's going to be positive now, so 6x plus 7 equals 6x plus 7. Really, we can stop there because if you look, we have the exact same thing on both sides. But just to finish it out, if I were to subtract 6x from both sides, what I get is that cancels out, and it's 7 equals 7, which is this time a true statement. And when I get a true statement, since those are the exact same thing, if we were thinking about it as a line, those would be the same line, and so that would be infinite solutions. Meaning it doesn't matter what number I put in for x, that you could get, you would always get a true statement. So the x doesn't really matter. If we look at it as a graph, they would be the same lines. So, looking down here at our information here, we're going to fill in, because equations can have, well, they can have infinite, and infinite, 1, or no solutions. So those are our options there. Infinite solutions mean that any number or any value can be substituted for the variable and would make it true. No solutions, there's no value or no number that can be substituted in for the variable to make the equation true. So, as you're solving these, you will undoubtedly notice some that have either infinite or no solutions. But let's just work out one here just to try it out and see. So, do this one in the middle. I'll distribute. I'll go pretty quickly for the video. So 3x minus 12 plus 2x. Oh. Plus it's a 2x, just trust me there. Just wanting to lag a little bit. Add those together, that gives me 5x minus 12 equals 5x minus 9. And you might ask, well, do I have to solve it out all the way for this if I notice, hey, those are 5 and 5x. These are not going to be the same. No, you don't have to. If you get to this point and you notice, hey, those are different, it's going to be false, you can do that. But just in case, subtract it out. Just cancel. I get -12 equals -9. And so showing those graphically, that would be, those would be my y-intercepts. And so this one would be no solution. If it'll finish writing for me, we'll see. No solution. There we go. Okay, so just a little preview of those special cases. Can work some more of them out, but hopefully that gives you a good idea of what's going on with this.